All right, so I've been working on this for too many hours today, and I want to share basically how it's going. So this is a setup that is pretty common for the FYDP so far. Here I've got one of the sensor boards. I've got it wired up with the GPS going over UART, high baud, whatever. It's happy. It's got green light. It's got a fix. Here we have our bridge board. It was in this little breakout board, but for the demo I wanted to sort of make the LED a little bit more visible, so it's just, they're both sitting in front of my computer right now. And then we've got the Raspberry Pi there. And so just a quick recap of how everything's wired up. The actual sensor board doesn't need to be wired into anything, it just needs power. We can get power over like a 5-volt battery, we can get it from a USB battery bank, we can get it over the lead that's sticking out right now. In this case, for the demo, I want to show you the flashing process and how everything works. So it's connected to my laptop. The bridge board is very similar, except it has two outputs. So there's the regular USB and then the UART output. Both of those are going to the Raspberry Pi. There's nothing else going to the Raspberry Pi. The cable behind the Pi is your power, and there's Ethernet. So this board here is not communicating to anything on the right half over anything other than this little Wi-Fi link. Wi-Fi/Bluetooth, it's technically ESP now, but whatever. So it's not a wired communication. I apologize for the wind noise, it's all of a sudden picked up. And so this is something we've been working on for quite a while, and I'll show you the setup. I'll put my iPad back down. Oh, my poster fell in the background. That's fine. Okay, so what we've got here is two windows. So I guess it's, why are you doing this? iPad, please. Okay, so we've got two windows. You can't see the window numbering here, but this is going to be on my laptop. So if it's the double pane thing, this is going to be on my laptop. It's an Intel Core i5, whatever, who cares? And then this one here, I guess I already did it earlier. This is going to be on the Raspberry Pi. So again, from this half onwards, laptop, from that half onwards, Raspberry Pi. It's on my laptop right now over Tailscale because I don't have a display hooked up to the Raspberry Pi, and it's running without a GUI. So but trust me, they're separate, okay? And so there's two things that we want to do here. The first thing is we want to flash the firmware for all of our boards. So this is going to be on the Raspberry Pi still. What we're going to do here, we can flash from the left. So we have three panes. We have a top pane, a bottom pane, and a left pane. The left pane is how we flash the dev kit. So this is the dev kit /C variant, C6. This is what we use for our bridge board because it has two functional USB/JTAG/UART outputs. One of the UART outputs on the actual bridge dev kit sensor board that you see on the left here had a little wiring mistake, so we can't use it. So we're gonna flash the board. This flashes over USB, so it'll run. We'll select, we want dev TTY ACM0, that's over USB JTAG. It'll flash, and then on the bottom pane here, you'll see this is actually a Minicom, Picocom technically, serial terminal that we see coming out of the bridge board. So that'll be the gray wire on the bottom, the black wire on top is the USB that we use to flash with. You can see here now we are in this directory here with our Pi RX receiver. We can run our track test. And so what this track test does is opens the USB port, which is currently held by my flashing firmware, and it allows us to actually simulate the I/O operations that we normally do from a switchboard from inside the vehicle. So we have things like ARM track capture, take location, and track capture and quit. These are things that we would normally interface with using a switchboard or a push button physically located on the vehicle. I don't have the entire switchboard set up right now, so I'm using this to basically simulate sending those commands over GPIO. Normally this would run as a systemd service and you wouldn't ever see any of the interaction here. The bottom again is what's coming out of the bridge board. So right now it's just enabled time synchronization between all of the boards. It's discovered all of the nodes. We only have one node in this instance. Normally there would be 5 or 6 other nodes. But we're not going to worry about that. Now the actual node itself, we flash. I can get rid of this window now. Okay, so this is reminder on my laptop, the ThinkPad. We're going to run the sensor board underscore floating binary. So this is slightly different than the regular sensor board binary in the sense that it essentially configures the position identifier of our aircon message to be floating other than something that's attached to the vehicle. And this is going to be the device that we like walk around with and are able to capture cone locations with. So I run this, it'll flash normally. This one can stay open. We're actually going to keep it open. I do actually want this pane on the left so we can see all the messages. So it starts the ESP now task. It does auto baud rate configuration in order to detect the proper GPS baud rate. We had a few issues with the GPSs sort of like losing their flash memory or not being configured properly, so auto baud rate to detect it. And in theory, we have a green solid LED, which means that we are seeing GPS messages. Now, the warning message of using the default baud is a little bit worrying because typically we end up parsing for the 6800. So let me reflash. Okay, well, let's see what happens. So what we can do here, arm stack capture, take location, and we get location. Okay, so I need to get rid of the warning message. I apologize. The green LED being solid means that we have a fix. So maybe I screwed up the firmware somewhere, but we're not going to worry about that too much. A few things what we want to notice here. So let me end track capture first. All of our track capture goes to this location here under DAC tracks, date, and then your time. So I'm going to remove all of these because I'm a horrible person and I want to demonstrate to you guys everything actually working. Okay, so we're in the tracks log, everything's good. Okay, so first things first, we'll notice there's a red LED blinking on the sensor bridge. This is blinking pretty slowly right now. It's basically just a heartbeat LED because we don't have one of those. On the actual board, you'll see a blue LED that's blinking really fast. That's a heartbeat LED that we use for the sensor board. It's actually technically a combined IMU alive / heartbeat. So it blinks fast when the IMU is active and slowly when the IMU is dead. But this is the one we care about, this red LED. When we arm for track capture, and normally you do this via a switch, you'll notice that the LED starts blinking really fast. And so this is like your visual indication when you don't have an interface to work with to see that we're ready to ingest data. And when you do this, it stops all of the actual data nodes on the vehicle from transmitting so that the actual floating node can get its GPS messages through. You'll see that the message comes through, received arm right there from the bridge. We'll see two of them because we just ran it earlier. Okay, let me go back to this window here and let me reflash really fast because I want a clean, yeah, okay, you'll see a rainbow LED when we flash. I added this because I had at some point multiple boards on my floor and I couldn't tell which one I was flashing, so I added 3 seconds of rainbows so I could tell which one's flashing. It doesn't mean anything. You saw it blink twice green earlier. That's what happens when we're trying to parse and understand GPS messages. But now that we have GPS messages, we should basically be good to go. So we're armed. We see that this red LED is blinking really fast. So then we can ask for a capture. So that we do using take capture, I believe. Take location. So when I take a location, a few things are going to happen. You're going to notice that the red blinking LED on the right board, the bridge board, is going to go orange. Oh, it's freezing rain into my window. Okay, I'll close in a second. It's going to go orange, which indicates that we're doing something, and then it'll either blink green or blue or red depending on how everything goes. You'll see a bunch of messages come out through the bottom window, and then you'll also see when we go back to the second window that we'll have sent 5 GPS locations. So we take a location, we show green to indicate success. We can do that one more time. We go orange, and then we go green once we get the location. Going back to this page, what we see here is we see 5 GPS samples after we receive a request for GPS capture, and then we do the second request there. We do 5 samples because sometimes one of the samples gets dropped over Wi-Fi, and we want at least 2 or 3 samples to make sure that there's not an insane amount of drift on the GPS. So the RPi averages those 5 samples to give you a cone number, a lat longitude, and an altitude. And if we go to our file here, we'll see that we now have a new file. If we look at that file, we can see that we have 2 cones, which is super awesome, super cool. Now, if we want to take one more location, look at the LED on the board. I'm not sure if you're going to be able to see it very clearly, especially once YouTube processes this, but the green LED here is going to turn orange very briefly when it takes a capture to indicate to whoever's walking around with a stick, mapping locations of cones, that we're doing something. Orange, and then back to green once we're done. And then because we took another sample, if we go back to this page here, we can see that we now have another sample for our cone. So all in all, this is a way for us to get the location of cones on the autocross course quickly by basically walking around, hitting a switch, taking location, and ingesting it into our software. Yeah, that's all. This was far too many minutes for a simple demo that I wanted to show, but very pleased about this. Thanks. Bye. Also, in case you were wondering, this is the setup. So that's the poster, my FYDP poster that fell down. There's another sensor node. That's the laptop. This is the keyboard I was using to control everything. So